Software is pretty amazing. So we have really good tool designers, and they get it right like 90% of the time. But with this software, it's 100% of the time. So what this is able to do, we put in the material data card for the stamping, whether that happens to be a dual phase like a DP980 or just like a traditional 340 megapascal part. We put in those parameters, we come up with the tooling strategy, and then this sims out if the part has too much thinning, too much compression, if the part is going to have a great deal of spring back, and then we can compensate and change our tooling strategy accordingly to make sure that we're getting a good part with as few hits as possible. So instead of maybe like a 3-hit part, we can manufacture the part in 2 hits but add some compensation into our tooling. And again, these parts have only in the past 10 years got significantly more complicated. Again, because of CAFE standards, you're trying to go with thinner materials of higher strength. So we're working with, I would say 25% of the components we work on now are advanced high strength steels or ultra high strength steels.
So when you're doing this, usually you're going to get thinning out on the radiuses and whatnot. Does that mean you have to design it so you can pull more material from the swarf or the scrap that's going to be taken away? Is that
Yes.
being told to you by the computer, or?
So yeah, this helps actually with the blank development as well. So where to actually have more material to pull on to get it flat, or sometimes you can just reduce the material in that area and then it just sucks right up into that. So you're actually not holding it. And it's a I'm not going to say a guessing game, but there's
Well, in the olden days it was a guessing game. I guarantee you that. Yeah.
Yeah, we're always trying to move any wrinkles or tears off part. We care about the on part being correct. If we're going to have any issues, we want to move that into the scrap portion, and we're going to cut that off in our laser processing.
Right.
Yeah, and this is so I was skeptical when we first got Autoform of just about how good it would actually be and how much it translated from the sim itself to real life.
Yeah.
But it is solid. It's like, I'm going to say it's 95% plus on what we're seeing on the sim for thinning and spring back, what we see in real life.
Actually, while we're looking at the FEA, why don't you describe what those colors and everything else means to the audience?
This is your spring back. So the red, the color map shows you right here how far off. Positive is up. Pink is down. So we're looking at 4 mils, 3 mils of spring back here right now.
So on this type of tool right here, Primo, would you have a restrike or would you try to compensate?
We'd probably try to compensate depending on the amount of parts that we're going to be hitting. But for the most part, we'll probably restrike just these ends.
Okay.
Because that's important, because these are usually the mating areas on the ends.
Yeah.
So this is your spring back. Then it'll also tell you wrinkling. So anything that's blue is perfectly fine, but over here is a little bit of wrinkling. But if you look back, it's like, it's really just a natural, the way the material kind of forms in that area. It's not really per se wrinkling, but it's
just not going to be as flat as the rest of the part.
Exactly.
You're going to have some puckering, but it'll still flatten out.
Yep.
What about thinning? Can you show us the thinning on that part?
Where is it? Right here. So around this corner right here is, well, where you'll get most of the thinning, but the rest of the part pretty much is within tolerance. I think the most is 20%.
Yeah, which is industry standard.
Yeah, that is. Yeah.
Yep.
So this is where we've come a long way in design for manufacturing feedback with our customer.
Wow.
Like in the past, we would have got this CAD file, we would have made the final hit tool. The guys out on the floor, these guys are artists. They would have gone out there and they would have padded those corners in. They would have figured out how to make it work.
Right.
But sometimes it takes just a little bit longer to do that, and then maybe you need to make another tool. Now, because of this software we have, we can go back to the customer in advance and say, okay, we're right on the edge, or we're over, like we need to adjust this radius now. They'll put it back into their system, they'll update their FEA, they'll give us a CAD file back, and then we don't have to go through at the tail end of
fix
trying
it,
to figure it
yeah.
out. We're figuring it out on the front end.
Front end loaded. That's kind of like what we're doing with every one of our customers. We want to front end load everything. Find out what's wrong, what's going to happen in the future, so we aren't basically scrambling at the end of a program. This is brilliant. I haven't seen this CAD system before, so I'm really impressed.
Yeah, and we're going to apply these same strategies to our plastic injection molding as well as our stamping. So anytime prior to cutting any tool, we're going to run these sorts of analysis to ensure that we are on the right path.